Hello and welcome to another demonstration video of Mysocket.io. It's been a 2 weeks since our last demo, and today I'm very excited to talk about Zero Trust again, building on our previous blog where we introduced identity-aware sockets for HTTP. Let's pull up that blog real quick, and today we're going to talk about an extension on that. So yeah, here we talked about introducing identity-aware sockets and enabling zero trust. And the use case there was really an alternative to VPNs and allow remote access to web services that might be running in your corporate data centers or in Amazon that you'd like to expose to trusted people, people that need to authenticate first, but not necessarily to everyone on the internet. And so you can read more about that in our blog from January 14th, a month ago. And today we're going to talk about the exact same set of features, but for TCP sockets. So this is an interesting, addition to that. And particularly I want to talk about SSH and Zero Trust. So Zero Trust is all around determining the identity of the user, authenticate that user, make sure that he or she is allowed through, and only if so, we will stitch together sort of the servers that you want to expose to the user that we have just allowed in. And so the user experience as an administrator of a server trying to make something available using Mysocket is very similar. So this is a command that you would use to create a identity-aware TCP socket. So in this case, we use the connect feature, which does also sets up the tunnel real quick. But the important flags here are -- cloud off, which will make this a protected socket. And then you'll have to specify which email addresses you want to allow. So in this case, I'm saying everyone that authenticates and has an email address of mycorp.com or one of these two contractors, right? So you can see the advantage here already. There's no need to set up a VPN and onboard the contractor. We just say, hey, everyone at mycorp.com and contractor@gmail.com or john@example.com has access to the service that runs on this machine, myprivate.shserver.com. Port 22. So that could be on local host. In this case, we're using the machine where we run this command from as a relay host if you want to, but it could just be on the server directly as well. And it's of type TLS. Okay, that's how you configure it. But how does it really work? Yeah, so what we're building is a per session authenticating firewall. And it's very powerful because every network flow now has an identity. So let's take a look at this example. So let's say that we have a client here on the left-hand side. This could be me on my laptop. And this is a very simplified example. I want to send the string hello to the TCP servers here on the right? But there's a bunch of security framework here in the middle. And it's quite a bit of work, but you'll see that from a customer perspective or an end user perspective, it's actually very easy to use. So step one, when I sent this hello string, I'm passing it through a new subcommand in the MySocketCTL helper tool called client TLS. And what's happening here, as soon as I do that, is a browser will pop up and I am forced to authenticate. So I authenticate using GitHub or Facebook or Google. And that results in sort of a yes or no from the identity provider. By the way, we'll also support SAML for those who are interested in hooking this up to their enterprise systems. So after that, we know for sure that the user that is authenticating is this user, right? We trust the identity provider, potentially with MFA and so on and so forth. Then we'll look at the authorization rules. Do any of the email addresses that we provided match the identity of this user? And if so, great, then the user is authenticated. Step two is for this user to generate a short-lived cert or certificate, a public-private key pair, and send a certificate signing request to the Mysocket certificate authority. As part of step one, it received a token, we'll sign the certificate, and we'll give it back to the client. Then step three is the same client will set up a TLS tunnel, an encrypted tunnel, to the secure edge points here, the anycasted Mysocket servers. There's this little friendly police agent here that will check if you are allowed to do so, and it's doing that by validating the certificate and say, show me your passport, And if you're valid, then we'll stitch together your session with the original listener that we wanted to make available, and the traffic is sent through. And then step 4, the hello packet arrives, right? So that's how it works very high level. But maybe we should look at a more practical example. So let's take a look at SSH. So instead of this hello example, this would become a SSH server that sits maybe in my corporate network or in Amazon. It doesn't have a public IP, or I firewalled it off, but I still want to make it available. So as an administrator, again, we would create the socket using the Mysocket CTL tool. This is really sort of the server side of things. Again, we'll say that these are the allowed email addresses. I'm enabling zero trust, and this is kind of what the output looks like after that. Notice also here, and we'll talk about that in a bit, that there is a SSH public CA, and we'll talk about that in a little bit. So first off, let's try to set up that same SSH session again. Again, we should pass that traffic through the Mysocket CTL client subcommand, which again will make sure that the browser pops up, the TLS tunnel is established, we'll have a ticket, and so on and so forth. And to make that work with SSH, you can use this function called proxy command, which basically sends all standard in and out through that subcommand, which in this case is the Mysocket CTL client tool. So once you do that, this is what the end user would do. This is basically what I would do at home. SSH, this particular socket, and voila, I can now talk to this SSH server and authenticate in using, whatever I was using before, maybe an SSH key or even username and password, right? But this is pretty powerful because what we've created is now an authenticating firewall. And we're no longer relying on trusted IP ranges. We actually look at the actual identity. So we did that by using client certificates and something called mutual TLS. Turns out that SSH is actually quite similar to TLS, and we can use very much the same principle. We can create a certificate authority for your socket to sign SSH keys, right? And so just as before, when the user was in step 2, requesting a TLS certificate to get through this firewall, it will now also ask for a SSH certificate. So it will generate the public-private key pair, and step 3, or as part of step 2, it will ask for a signing request of that key pair. And then once it gets through, it will present that signed SSH key to the server. So to make that work on the server side, again, this is all optional. You can still use the old method for the authenticating firewall. Just to repeat, this is just to make sure that you also want to leverage the Mysocket certificate authority to provide SSH access. To do that, you need to add these 3 commands. So basically, you enable your SSH server for a trusted CA, which is the CA that we showed earlier. You can do that with Mysocket's CTL socket show, and it will show you the key. You'll put that in this file that you referenced here, etc sshd config. We'll also mention that we need principal file, and in this case, we say the principal file will live in the home directory of the user. So what is a principal file? It's kind of what this is, this command. So every SSH signed certificate will have one or more principals in it. And so these principals are added by in this case, Mysocket certificate authority for your socket. And by default, we'll put 2 principals in there. The first one is the email address of the user that authenticated. And the second one is a string called Mysocket SSH signed in this case. So basically what we're saying here is everyone that has the principal Mysocket SSH signed maps to the user Ubuntu. That's kind of how SSH works. So you can see the setup is pretty quickly. You reload the SSH config and you're good to go. And then we need to make some more changes to the SSH config on the client side as a user. Again, this is a one-time setup. You basically need to add this to your SSH config. And now it will also tell to request a SSH key signing for that particular host. And once that's done, we'll set up the TLS tunnel as well. Let's take a look at what that actually looks like. So if we move on a little bit, I have set up a SSH server for you guys to test with if you're interested, just to see what the experience is like. Again, I don't know who is going to test this. I can't give you a username and password. I cannot upload your SSH key to the server, but yet I want to demonstrate how easy it is to do that. So I already set up the server, just like we said before. In fact, the server runs on DigitalOcean right here. You could see this, it has a public IP, but it is completely firewalled off. You could see here I enabled some firewall rules. Outbound is all allowed, but inbound there are no rules, which basically means deny any. And I can demonstrate that by maybe doing a quick ping and see it doesn't work. I can try and connect to the SSH port, and it doesn't work, right? But I still want to have access. So I'm going to follow with you guys how to set this up as a user. This is, again, a one-time setup. So I'm going to download the Mysocket helper tool. I'm going to move it to user local bin. All right, so now I have it. Let's just double check. There we go. And I need to add this to my SSH config file. So you can just copy paste that. There you go. And now I should have that in my SSH config file. I already added it a few times, but this is kind of what that looks like. And with that, I should now be able to SSH to this server or any other server behind Mysocket. So copy paste that. Again, you can try this too. So I'm going to do that. So what you see here is a browser is popping up magically. So I'm going to log in with Google. So make sure if you do this to also log in with Google, because this socket has been provisioned to only allow Gmail addresses. I'm going to assume everybody or a lot of people have Gmail addresses. Okay, so I am now logged in. So if I go back here, you can now see that this flow was successful. I'm not giving you guys a real shell, unfortunately. Some of you may abuse it. So it's just a little dummy shell, but you can see I'm logged in. You can see also how easy it was. I'm going to exit here and do this one more time, because obviously this one-time setup took a little bit of time. But let's say I want to SSH again. I want to just show you how fast that is. So I'll do this. Thing comes up. My identity provider has already cached this, right? So this is really fast. And in the background, I'm already logged in. So you see how we've now built this additional security, maybe even better, but not at the penalty of user-friendliness. All right. So let's go back here. Let's wrap up. What we showed in this demo and in this blog post is how we introduced TCP aware or TCP identity aware sockets, leveraging and building on top of what we had earlier. And we do that by leveraging TLS tunnels. We also demoed how we can use the certificate authority that we also added in there to make SSH Zero Trust really smooth. Again, you can just use it as an authenticating firewall, but you can also take care of the authentication, which is really powerful, right? Like if you have folks, new people joining your company or people offboarding, that typically means moving keys or rolling passwords and so on and so forth. In this case, no keys are needed, no passwords are needed. All you need to do is remove that user from your identity provider, which may be your Active Directory or maybe Google G Suite or something like that. So on top of that, what we built here is a cloud-delivered authenticating firewall where every flow has an identity to it, right? Which is very powerful. We know exactly who is that, and we know that user was authenticated and authorized. And what we're doing now is basically, if you think about this as a firewall, we're replacing the trusted IP addresses that we whitelisted with trusted identities, which is obviously a lot more precise and exactly what we wanted. So I hope you found this interesting. Give this a try. If you have any questions, just reach out to me. Always happy to chat. Thank you very much.